Hallo, ich heiße Sergei Golubchik, aber mein Vortrag ist auf Englisch, so yeah, let's get on with it. So first, a little bit about me. I'm originally from Kharkiv, Ukraine. Now I live in Germany. I was core MySQL developer since 1998, and in 2010 I've moved on to MariaDB. So my day job is MariaDB, and yeah, sorry, actually. This talk is not about MariaDB, but I have a lot of MariaDB stickers. If anybody is interested, I just put them here. So, yeah, in 2012, I've moved a MariaDB packaging that was based on spec files to build RPMs with CPack. And this talk is based on our more than 10-year experience of using CPack RPM for building RPM packages. Yeah, currently I'm a VP Server engineer in MariaDB PLC and a member of the MariaDB Foundation board. Let me start from describing who is this talk for, I mean the main use case. So supposedly you have some kind of project that is built using CMake, and understandably you want to produce packages out of whatever CMake builds. And for the user convenience, you want to produce different kinds of packages, like source packages, binary packages, I don't know, tarballs, RPM and deb for Linux, PKG packages for FreeBSD, macOS, Windows, whatever. And well, not all of them, but at least subset of that. And supposedly you consider use CPack for that because CPack can build all this and more, and from the same set of configuration files. So you don't need to configure every packaging tool separately. And you get similar configurations, like you get the same names and same set of RPMs and Debian packages. You get same files in the same places in all the packages. And if you use window packaging with GUI, then it'll open a list of groups, categories to select from, and they'll match RPMs, set of RPMs and Debs. I mean, configuration will be similar for all those tools. That's why CPack is great. But this talk is not about CPack in general. It's specifically about how to build RPMs with CPack. So I'll be mostly talking about RPMs here. So first, let me start describing how that worked for MariaDB. We used to build RPMs the traditional way, using spec files and RPM build. And the problem is that spec file, it lists all the sub-packages that had to be built, what files go into what sub-package, and it tells how to invoke CMake. Then RPM builds invokes CMake. CMake does its thing, determines the system configuration, what components has to be built, what files go there. And then CMake configures the build, and this configuration that CMake produces must match what spec file had in the very beginning. Otherwise, well, RPM won't build. RPM build will fail. So it kind of backwards because you have pre-recorded configurations somehow. And then you need to force CMake into producing exactly the same configuration. It's not natural. And our problem was, so we built MariaDB on many different Linux distributions. Back in 2012, it was from CentOS 5. Now it's CentOS 7 and SUSE 12 are the oldest ones, and the newest are Red Hat 9, Fedora, Rocky, Alma 9, and all those things. So they have different libraries of different versions, different sets of libraries, different command line tools, different versions of compilers, and we built on all that. We built with variable number of sub-packages. For example, there's RPM that corresponds for MariaDB compression plugin with library Snappy, which I vaguely remember is not present in like either SUSE 12 or CentOS 7 on something old Linux. Then, and on the other hand, compatibility packages are not present when we build on the newest Linuxes, newest distributions. Then there are different packages, number of files in different packages. It also changes between distributions, and of course dependencies are different. And we need to build all that, and we don't want to have spec files for every single Linux distribution. That would be unmaintainable. So the old approach to satisfy all those requirements was we basically had a bash script that was running before the build. It was checking the environment, the Linux distribution. It was using sed to modify the spec file, and then RPM build was building out of that. It kind of worked. It was very fragile. It was breaking often. It was high maintenance, needs to be updated every time, and it required advanced spec file knowledge that none of us had. And then we switched to using CPack, and that worked in the opposite direction. First, we run CMake. CMake configures the build. CPack has all the information that CMake collected, and then it generates spec file that corresponds exactly to this build, to exactly this build configuration. So spec files are always correct, and they don't need to be maintained because, they're generated every time, and they exactly match the build, exactly match whatever Linux distribution we are building on. And that actually worked very well. The whole transition took maybe 1-2 weeks to write to convert spec files to using CPack. Now it's very robust. We have that over 10 years. It breaks very rarely, like almost never breaks. It doesn't need to be modified or updated because it adjusts to the build automatically. Whenever we add new sub-packages, we have packages for plugins. Whenever we add a new plugin, whenever we add new executables to some packages or add something depends on new libraries, that's new dependencies, or remove something, RPM packaging just adjusts automatically. We don't need to change anything. And we didn't change Debian builds yet, still. And most of that, and like maybe except for the last couple of years, Debian builds literally were very, very fragile. They use still this approach with bash and sed. And they were breaking, like, I don't know, every second day, maybe 3 times a week. And we literally, I mean, I'm not exaggerating, it was literally 100 times less problems with CPack RPM packaging than we have with the traditional Debian packaging with control files and rules and all this stuff. So we were very, very happy with the results because it's kind of thing you do once and then you don't think about it, it just works. What we have now with the CPack RPM packaging, almost everything is dynamic. So number of packages, number of files, dependencies, that all depends on how we build, depends on the build configuration, depends on the Linux distribution we build on, and it adjusts automatically. With one command, we build like 40 to 43 different packages, depending on the Linux distribution. Different packages have different versions, different licenses, different vendors. Whenever we add something new, it picks up automatically. Those RPMs are generated, and they have automatically correct build dependencies, which again, with Debian builds, people generally, when they add a new dependency, they don't think about updating Debian files. So the next Debian build in the CI fails, then we fix Debian build. And if dependency is removed, Debian build doesn't fail, so we just have old redundant dependencies unless a few years later somebody does spring cleaning. And with RPM, it's never the case. The dependencies are always correct. From the one file, we support all the Linux distributions that we have. And even RPM packages can be built on non-Linux distribution. Like I have Gentoo on my laptop, and I can build RPM packages just fine. It's not packages we release because we want the release RPM contain exactly libraries with the versions that a particular Linux distribution has. But it can be, I can do development of RPM packaging on Gentoo. Okay, so that was how we did it, and now let's move on to RPM primer. As I said, there will be a small example, a very small. What is? Okay, so it shows the previous slide. Yeah. Interesting. Okay. Yeah, but it doesn't show on the normal screen. So yeah, there will be a very small. I will just do a very small project with a couple of files and start building RPM packages out of it. And yes, I forgot to say in the beginning, if you have any questions about any of the slides, just interrupt me and wave your hand or say something, and then I'll just stop and answer. So this is the very small project I'll be talking about. Also an example.c, we are just prints hello world, nothing fancy. and a small CMake file to go with it. Again, this is not a CMake talk, so I presume you know what CMake is and how it works. But if you have a question about any of the lines on the screen, then just ask. So we're building executable code example from the source file .example.c, and we install it as a binary example and so on. And as good CMake practices usually are, I have a separate directory for the source code and special for the build. So now I switched from source to the build, and I run CMake, specifying where the sources are. CMake runs, detects the versions, and so on. Then I run make, it compiles something. And then I run CPack -g RPM. CPack has a notion of generators. Generator is something that, well, generates a specific kind of packages. It has generators for RPM, for Debian, for zip, for Windows, for Wix, and others. And here I'm invoking RPM generator, and it doesn't work because we didn't enable CPack. So okay, let's add a line that enables CPack in the project. This is how you enable CPack. You include the CMake module called CPack. And now we run make again. It regenerates whatever files are needed. CPack -g RPM, and you see CPack runs. It generates spec file, and it generates an RPM. So let's look inside. This is the RPM that was generated. There are a few. It's basically, well, it works. RPM didn't produce any errors when examining it, but it's still not exactly perfect. So the name looks strange. It's not the name I used to see in normal RPMs. So in repositories, the license is not set. The vendor is, well, Humanity, but I'd prefer a more specific vendor. Any description is automatically generated and doesn't mean much. So let's fix that first. So now I'm going back to CMake list, and I add lines to specify the vendor, the license, the description. And the last two lines tell that RPM build should use the default RPM name as customary on the particular Linux distribution, and the release name should be part of and distribution name should be part of the release number, so it should be part of the RPM. And the last line is basically requirement on Red Hat and CentOS. Run make again, and this time you see the name is a normal name that you used to see in different RPM packages. So we fix the name, and analyzing the file, you can see that the license is set, the vendor is set, the description is set. So this is basically a normal RPM, and if somebody would actually need a package to print hello world, this could be pretty much distributed, and people can download it and install it, and it will just work. So this is a fully correct, complete RPM. Let's look in the other fields. So provides are set correctly, requires are also set correctly. It doesn't need anything actually except libc. And the list of files, yes, this is our example binary, and the build ID. So yeah, this is a normal RPM which basically can be already distributed, and just with few lines in the CMake file. I'll diverge for a few seconds and I'll build a binary tarball. I just need to specify a different generator, no other changes at all. Well, so I just run a tool differently. And it generates a tarball, and looking at the tarball, this is our binary example. So yeah, this shows how you can build different kind of packages from the same source directory, from the same build tree, which is basically almost about how we do that in MariaDB. But because I'll be talking about RPMs, I'll write in the CMake list file that I'll be using RPM generator. And after writing that, I don't need to run CPack -g. I can just use make package, and it'll do everything. It'll run CMake, it'll build, it'll run CPack, and then we'll get our RPM. So that works. Now let's see how dependencies are picked up. Here I'm adding a dependency on the cursors libraries. So it's CMake, it'll detect where the cursors libraries are, and then I'll link with cursors. Hope everything is clear here. If not, ask me. So I'm running make package. As you can see, CMake finds cursors. relinks the binary with the new library, and generates the RPM. And if we look in the requires, yes, cursors are part of the requirements. They're picked up automatically. This is what RPM builder is doing, so this is not specific to CPack, but dependencies are picked up automatically and works as needed. If somebody would install this package using, for example, DNF, DNF would know that it needs to install a package that provides those libraries. So this example binary would depend on cursors. Let's do something more interesting. Now I'm adding, yes? This one?
Yes, exactly. So how do I treat it if I need specific package names? So maybe I have specific name of the package that I depend on.
I'll talk about that later. But this is not a dependency I'm doing for RPM. This is dependency I need for the build. I need CPack that I need to link with. This is how if my package needs to just to compile to link. If I need a specific RPM level dependency, then I'll do that later. But here, it doesn't also know what packages it depends on. It knows that it depends on the library. So DNF, for example, will look for the library, for the package that provides those libraries. It will not look for the package by name. And about other dependencies, I'll talk about that. So here, I'm adding another executable. Again, this is just, I'm specifying to CMake that I want to build executable called atool from the source file tool.c and install it as atool. So it's, again, nothing RPM specific here. I'm just adding a new binary to the build system. And yeah, because I don't want to write another simple C file, I just copy example.c to tool.c. Then I run make package. As you can see, it compiles tool.c, it links it into atool, and generates the RPM. And if we look inside the RPM, you can see that RPM picked up a new binary automatically. There's a build ID, there's a binary, so we don't need to modify a list of files inside the spec file or anything. CPack gets all the targets, all the files that were supposed to be installed by the CMake, and automatically puts them into the RPM into correct places. So there's no need to maintain a separate list of files in the spec file. But now, what if? So it's a tool I want to have it in a separate package. I don't want to have it in the main package. This is done using components. I'm specifying here that a tool is installed into component tools, and I enable component install for CPack RPM. And when I build that, you can see that it installs two components because component install is enabled. But the name of the RPM is, again, not as I want to, because I don't want example dash unspecified with this strange capitalization. I just want the old example name. I need to tell CPack that unspecified is the main component. And after that, you can see, yes, this example as it was before, and that's a separate RPM example dash tools. And looking inside, example binary is in the main RPM, and a tool is installed as a separate package. So there were basically one configuration line to enable component install. And here, if I would be generating Debian packages, again with enabled component install, then a tool would be a separate deb package. If I would be doing GUI install on Windows, it would open a window asking what components I want to install. There would be main one and the tools one. So this component thing is not part of CPack, it's part of CMake, and it works for all packages that I would generate, no matter what the type is. And it can be also done conditionally as well. Here in CMake, I specify the tools should only be built unless without tools is specified. And now I run CMake and I specify without tools. And if you look at the end, you'll see that only one RPM was generated. So tools RPM was not generated at all. CMake tools was not compiled, not installed, and not generated a package. So the subset of packages that is generated, the set of packages that is generated, it can be changed basically every time you compile. You can specify what packages you want to generate or packages you don't want to generate. There's nothing that is hard-coded into the spec file and specified in advance. Everything is dynamic. It can be changed anytime, whenever you compile, depending on the CMake options, on the existing libraries, and all those kind of things. And a last thing I want to show in this primer, it's how to generate source RPMs. So I've specified CPack generator RPM, and CPack source generator is, well, it's what generator CPack will use for source packages. And in this case, I also want an RPM. I want source RPM. So I just add this line, CPack source generator RPM, and I run CMake and package source. And you can see it generates perfectly normal source RPM. And then I can use RPM build on this source package, and it'll build all those two RPMs that I've just had on a few previous slides. So just one line, and it generates a fully normal working source RPM. Again, we also use it in MariaDB, and one can download MariaDB source RPM and build from it everything without, cloning from the GitHub. Yeah, this is the name. Yeah, and there are a few more CPack RPM features. Well, there are a lot of more CPack RPM features, but few of them I'm showing on this slide, which I did not put into the primer. So with the first line, one can enable debug info packages. And if I would have had that in the example earlier, then it would have generated example-1.0 and example debug info. It will generate debug info RPM package for every RPM package with binaries. Then one can add more defines directly straight into spec file. This is useful if you use scriptlets that I'll have on the, closer to the end of the slide. And this is how you specify provides, requires, and all those stuff explicitly. So RPM builds automatically detects when a binary depends on some libraries. But if you package a shell script that invokes, I don't know, sed, for example, then RPM build will not detect it automatically. It's something you need to specify explicitly. And this is how you can specify requires per package. And if you can see, let me select this component name here, you can specify all those provides and requirements and conflicts per component. Like there is one RPM small package will require sed, and the other one won't require sed. So all those settings can be done per component. But debug info cannot be done per component. Debug info is global. It's either all packages have debug info or all packages don't. Then you can, of course, specify scriptlets with the CPack RPM. I have only 3 here, but you can have you can actually have all the 6. It's easy to deduce what the names are. You can have pre and post install script. You can pre and post uninstall and pre and post trans scriptlets. All that with the appropriate variables can be done, and yes, we also use that. And the last thing on this slide, so as I have shown, the file list is generated automatically, but sometimes for some files you want to specify additional attributes like file permissions or ownership or config no replace, and you can do that manually. So you specify this manually for files that, well, are special, and all other files are appended automatically by CPack. So you still don't need to have a full list of files here, but only all those exceptions where you need some special information on them. This is what CPack RPM can do. And I'm afraid I was talking too fast, so we are going to the final part of the talk. This is the thing I actually love about CPack RPM. It's very extendable. So I'll be talking about a couple of ways we use to extend it, well, in MariaDB source tree. So one thing I've mentioned that when we generate source RPMs, we have automatic build dependence. Now, this is not what CPack RPM automatically does, although I personally think it should be doing that. But this was a solution that, I don't know, took maybe a couple of hours to do. And we've done it, I don't know, I've done it like 5 years ago, 7 years ago. So because CPack is run from within CMake, it has access to all the information that CMake has. It knows all the targets, it knows all the binaries it installs, and when CMake performs detection of the environment, like where the specific library is, where the specific header is, CMake stores all this information into CMake hash, and CPack has access to all that. So we have this small script called build depend CMake, which goes for the CMake cache, and for every file which is specified by the path, compilers, Git, assembler, whatever executable we need, whatever library CMake found that it needs, it determines what package this file belongs to and appends everything to CPack RPM build requires. And again, this was written once, maybe 7 years ago or 5 years ago. Since then, nobody ever touched it. Nobody ever thought of that. Again, it just do it once and forget. It just automatically works. Requires absolutely no maintenance. If I'll click on that, yeah, we have internet. So this is the script. It's rather small. I don't know if I can create it here. Yeah, this is how it works. It's straight from GitHub, and this is, for example, the command to determine the package name from the file name. Yes. And the second trick, so this is a neat trick and very powerful one. What happens when CPack -G RPM is run? It needs to generate a spec file for every single package. To do that, it invokes CPack RPM.CMake file. It's a standard file. It comes from the CMake installation. It's installed in USR share CMake something. And this file looks into all the variables that I've shown, CMake, CPack RPM underscore something, and generates a spec file. What we can do, and what we are actually doing, you can create your own CPack RPM file and put it in the CMake module path before the standard CPack RPM. In this way, CPack will invoke your CPack RPM and not the main RPM, not the main file to generate specs. And this allows you to do a lot of tricks to modify CPack behavior. We used it, well, since the day one to fix some CPack RPM bugs. But since then, we expanded it to implement new features. Like you have seen that you can specify some information per component. You can specify script list per component. You can specify dependencies requires per component. You can specify, of course, description per component, because different components might have different description and different name. But you cannot specify license or vendor or version per component. CPack RPM doesn't allow that. They assume that all components have the same license and the same version. And when we build MariaDB, we have the main server, which is GPL, and we have the client library, which is LGPL. So we do need to change the license and the version and stuff. And post-trans, I have shown that CPack RPM supports that, which is true, but it supports that only for the last maybe 2-3 years. And we have all the CMake on all Linux distributions. So we also add post-trans support for all the CMake, and have some other checks from this file. This is how one can implement per component license by overwriting CPack RPM. So this file, you need to create a CPack RPM file, put it under this path, where CPack module path is somewhere inside your source tree. And then you can simply define CPack RPM, component name, package license, as if it was a normal feature supported by CPack RPM. And what it does, it simply takes the normal global package license, just do backup. And if package license per component is set, this is the name of the current component. And remember, this file is invoked per component by CPack. I just copy the per component value into the global value. And then I unset the module path and invoke the system CPack RPM. So this way, whenever I have per component CPack RPM, I override the global value with the local value, run the system thing which generates the proper spec file, and then I restore all the variables. This way we have with this trick, we have those per component license, per component vendor, per component version. So this was this and that one. This was and that one. It's all the extensions we have. Never needed anything else, and it allows us to use, well, CPack RPM, and it fits all our not very simple packaging requirements. But that was enough. So as a summary, and I think I've done in half an hour. So CPack RPM, it's a high-level approach to building RPM packages. So if you don't need to write spec files with those percents manually and run RPM build. So if you think of spec files of an assembler, this is, I don't know, like Python. And it's easy to use. As you've seen in the primer, it takes maybe a few lines, like 5 lines, to have a proper working RPM with all the fields set and everything that basically could be distributed. But it's also feature-rich because if you need to do more than those 5 lines, you can add, I don't know, 5 more lines or 10 more lines and have a rather complex packaging solution already with literally, I don't know, 20 lines of code. So yeah, what I've often see outside of CPack is just a bit of philosophy that I've just thought of. If something is very, very easy to use, then it's very easy to start to use. But then if you want to do something complex, then it's just not extendable. You cannot do something complex. Or you need to fight more with the tool than with actually implementing the solution. This is really not the case here. It's easy to start using it, and it's not very difficult to use all the features of it. It's very extendable, and the core thing of why is it extendable, because you run it from inside CMake, so you have access to all the information that CMake has. Like I had access to all the dependencies that CMake found, so I can convert them into the build dependencies. And it has access to all the targets, all the components, everything. And there's a rather powerful scripting language, that's CMake scripting language, that can be used to process all this information that's available inside CMake and convert it into, spec files that do exactly what you need them to do. And it's very robust because, again, as I said, we basically, pretty much nobody, maybe except me, thinks about those RPM packaging. It just works, it just never breaks. And it automatically sets all the fields, does dependencies, everything. New packages, when somebody adds a plugin, new package automatically appears. When somebody moves an executable from one package to another, it just automatically picked up again, a package is automatically updated. So you basically don't need to think about that at all. You just can develop your project, add tools, add dependencies, packages, and they'll all automatically be packaged and appear. And it just adjusts as the project grows. So it actually works very well for us, for MariaDB. And we have rather complex packaging requirements. So it's quite possible that your project has slightly less complex requirements. And if it works for us, it'll very likely work for a project too. That's what I wanted to show on this talk. Any questions? I also have, I thought it's better to have everything on the slides. So to have like one self-consistent presentation. But I also have a terminal screen with all those files, so I can show how commands run and everything. But it'll be just copy-paste from what I had on the slides. So are there any questions about anything I had? Okay then. Oh, yeah, sure.
Thanks for the presentation. Anyways, so does the kind of CMake dependency tree kind of expand to all those sub-packages as well? So if I kind of change one of the, so a file that is going to be packaged in one of those RPM sub-packages in the end. So I change that file. Will only that specific sub-package be rebuilt, so that sub-RPM be rebuilt, or will all the RPMs rebuild in the end?
Yes, so let's, I don't know, look at this one, for example. Whatever. Anyway, yes, if you modify a file, then make will look at timestamps and rebuild only those files you have modified. That's how make works. But CPack always packages everything, so it'll regenerate all the packages. CPack is not make, it's not looking in timestamps, it just packages. It's like make install. If you modify one file, then you run make install, it'll still install everything. It won't just install one file. And CPack works not the same way. It performs a local install and packages.
Oh, thank you. I guess there are other questions. I do have one more. So you said kind of the source RPMs are optional. So does that mean by default CPack does not build a source RPM first and then kind of a binary RPM, or
no,
but goes to the
no, CPack
RPM
RPM does not build a source. So it's a separate command that might make package source to build a source RPM and make package to build a binary RPM.
Okay, so you don't have a guarantee that the source RPM actually builds into the exact same binary RPM as...
No, not automatically. We have this check in our CI.
Okay.
We build binary packages, we build source packages, we build binary packages from source packages on a clean VM to make sure that it pulls all the dependencies and it builds, and then we verify that it builds exactly what was before.
Thank you.
You're welcome. Okay, thank you.